Late summer is the season most people waste food. Tomatoes ripen all at once, apples fall faster than you can eat them, herbs grow faster than they can be used. Most of that food ends up rotting, composted, or thrown away. Not because it wasn't valuable, but because modern kitchens are not designed to preserve abundance. Before refrigeration, households didn't panic when harvest peaked. They preserved food calmly, deliberately, and in large quantities. Drying was one of the most reliable methods because it required no fuel, no machines, and no ongoing cost. Properly dried food takes up a fraction of the space, keeps for months, and can be stored safely without electricity. It turns short harvest windows into long-term security. In this guide, you'll learn how to build and use a passive solar food dehydrator, a system that allows you to preserve large amounts of food using nothing but sun, air, and time. Food preservation through drying removes the moisture that allows decay to occur, and a passive solar dehydrator accomplishes this using only the sun's heat and natural air circulation, producing shelf-stable food that stores for months without electricity or mechanical equipment. This system has been used reliably for thousands of years because it works with basic physics rather than against it. And once built, it operates indefinitely with no moving parts, no maintenance beyond occasional cleaning, and no operating costs. The real benefits are straightforward. You reduce food waste by preserving harvests that would otherwise spoil. You reduce dependence on refrigeration by storing food that remains safe for months. You reduce the space required because dried food is lightweight and compact. And you eliminate the ongoing energy cost that electric preservation demands. In this guide, you will learn how to build and operate a passive solar food dehydrator, understand the principle that makes it work, recognize when this system is actually the right choice for your situation, and learn the decisions that separate reliable results from wasted effort. The core principle is straightforward. Moisture enables decay, and removing it stops decay. When you expose food to warm, dry air that moves continuously, the water in the food evaporates and is carried away by that moving air. The warmer the air and the drier it is, the faster this happens. This is why food dries in arid climates and why it spoils quickly in humid ones. A passive solar dehydrator creates these ideal conditions by using the sun to heat air inside an insulated box, then allowing that heated air to flow through the food and escape, taking moisture with it. This cycle continues as long as the sun heats the box, and the food dries progressively until its moisture content drops to a level where decay cannot occur, typically around 10 to 12% by weight. At this moisture level, bacteria, mold, and fungi cannot grow, which is why properly dried food remains safe indefinitely. However, this system only works reliably in climates with at least 60 days of consecutive dry season. If your region has frequent rain or sustained high humidity for more than half the year, drying will be slow and unpredictable. The physical setup is simple but purposeful. You build a wooden box oriented toward the sun, cover the top with a transparent panel to trap solar heat, paint the interior surfaces black to absorb that heat, and create vents at the top and bottom so air can enter, heat up, rise through the food, pick up moisture, and exit. Inside the box, you place multiple horizontal trays made from food-grade mesh or screens, not solid surfaces, so air can flow freely around each piece of food. The angle of the transparent cover matters. It should be tilted at an angle roughly equal to your latitude plus 15 degrees, which maximizes solar capture throughout the year. The size is flexible but should be practical to build and operate. A practical dehydrator is typically 4 feet wide and 8 feet long, which allows you to reach the center from either side without stepping into the drying chamber and uses standard material dimensions efficiently. The height inside should be sufficient to stack multiple trays with adequate spacing between them, usually around 3 to 4 feet total. The frame can be built from dimensional lumber, such as 2x4s, and the transparent cover can be polycarbonate sheets, acrylic, or glass. Glass lasts longer and transmits light with minimal distortion, but costs significantly more. Polycarbonate is durable, transmits light well, and is more affordable. The key is that the material must be transparent to allow sunlight through without significant loss, and rigid enough to support its own weight, and resist wind pressure without sagging or crocking. Do not build larger than 8 feet long without experience. Start small and expand after you understand how the system behaves in your climate. The interior surfaces that face the food should be painted matte black to absorb solar radiation and convert it to heat. The vents at the bottom should allow cool outside air to enter freely. The vents at the top should allow warm, moist air to exit without restriction. This creates a convection current. Cool air enters at the bottom, the sun heats it inside the box, it rises through the food, picking up moisture, and it exits through the top. The critical mistake that prevents consistent drying is inadequate ventilation. Many people seal dehydrators too tightly, thinking this traps heat more effectively. In reality, when air cannot escape, it becomes saturated with moisture and can absorb no more water from the food. A sealed dehydrator will rot your food instead of preserving it. The solution is to ensure that vents are sized generously enough that air can flow freely. A rough guideline is that the total vent area at the top and bottom should be at least 5 to 10% of the interior floor area. If your dehydrator is 4 feet by 8 feet, the total vent area should be at least 16 to 32 square inches distributed between top and bottom. The sun heats the air faster than it escapes, so the interior remains warm while moisture is continuously removed. If you're uncertain, air toward more ventilation. You can always add baffles to reduce air escape later, but you cannot fix a batch of moldy food. The food preparation is straightforward but requires consistency. Slice vegetables, fruits, and herbs uniformly, roughly a 1/4 inch thick. Uniform thickness is important because thin pieces dry before thick pieces. Thinner slices dry faster, usually in 2 to 3 days. Thicker slices take longer, sometimes 5 to 7 days. Arrange the slices on the mesh trays in a single layer with space between pieces. Do not overlap pieces or stock them. The trays should be spaced 3 to 4 inches apart. One mistake that looks efficient but fails: stacking trays too close together to maximize capacity. You will lose drying efficiency and end up with partially dried food that spoils. It is better to dry fewer pounds successfully than more pounds that fail. Drying time depends on 3 factors: air temperature inside the box, humidity of the outside air, and thickness of the food slices. On a warm, dry, sunny day with outside temperatures above 70 degrees Fahrenheit, the interior typically reaches between 110 and 140 degrees Fahrenheit, which is 45 to 60 degrees Celsius. Most vegetables and fruits dry completely in 2 to 4 days at this temperature. On cool, cloudy, or humid days, drying takes longer. Practical decision: if drying stalls at day 2, remove the batch. Partially dried food will develop mold, not finish drying. Wind helps because it carries moist air away from the dehydrator more efficiently, so positioning the dehydrator to catch prevailing breezes improves performance. Test whether food is adequately dried by bending a piece. If it bends without breaking, it still contains too much moisture. If it snaps cleanly or shatters, it is dry enough. The target moisture content is between 10 and 13% by weight. Do not over-dry food to brittleness. Slightly under-dried food that bends is preferable because it rehydrates better and retains more flavor. Foods that dry well in a passive solar dehydrator are those with high water content: tomatoes, apples, pears, berries, peppers, onions, and herbs. Leafy herbs like basil or oregano dry in 1 to 2 days. Thicker items like apple slices take 3 to 4 days. Some foods do not dry well. Avocados and nuts oxidize and turn rancid. Leafy greens dry too quickly and turn to powder. Do not waste effort on these. Meat and fish require careful handling because they are prone to bacterial contamination. If you are uncertain whether meat has dried adequately, do not eat it. Once food is dried, storage is critical because even dried food can reabsorb moisture from humid air and develop mold. Store dried foods in airtight containers in a cool, dark, dry location. Glass jars with tight-fitting lids are ideal. Food-grade plastic containers work well if they seal tightly. Store in a pantry or basement rather than a kitchen near steam sources. Properly stored dried food keeps for 6 months to a year, depending on the food type and storage conditions. One mistake: storing dried food in a sealed container without checking it for 3 days. If any moisture remains, mold will begin growing immediately. Check your containers after 3 days. If you see condensation, remove the food, dry it further, and repack it. A single 4 by 8 foot dehydrator can preserve 100 to 150 pounds of fresh food per season in a climate with adequate sun. This is a substantial portion of a family's annual food preservation needs and represents significant food security. The system requires no electricity, no replacement parts, and no maintenance beyond occasional cleaning of the transparent cover if it becomes dusty or cloudy. The cost to build a basic dehydrator is typically $200 to $500, depending on material choices and whether you use reclaimed materials. If you use salvaged wood and plastic, costs can be lower. This is a one-time investment that produces results for decades. Do not expect to preserve your entire harvest with a single dehydrator. If you grow substantially, you will need 2 or 3 dehydrators running simultaneously. The reason this system is reliable long-term is that it depends only on principles that do not change. The sun will continue to provide heat, air will continue to move, and moisture will continue to evaporate when exposed to warm, dry, moving air. There are no mechanical parts to wear out, no electrical components to fail, and no dependency on external infrastructure or supply chains. Once built, the dehydrator works the same way in year 10 as it does in year 1. The transparent cover may eventually need replacement if it becomes permanently cloudy or damaged, but this is a simple repair that takes a few hours. The real limitation is climate, not equipment. Build this system only if your region has a genuine dry season. If you are guessing, observe the weather for 1 year before investing. This is a system worth building because it solves a genuine problem, preserving food without electricity or purchased equipment, using materials that are readily available and methods that are straightforward to execute. The knowledge required is minimal, the failure rate is low if you avoid the critical mistakes of poor ventilation and unrealistic expectations about climate, and the result is reliable food preservation that functions indefinitely in suitable conditions. Once you have built and operated a passive solar dehydrator successfully, you will have gained practical knowledge of how solar energy can be harnessed for useful work, and you will understand why this method has persisted for thousands of years. Be honest about your climate first. If your region has more than 6 months of wet weather per year, this system will not serve you well. The right tool for your situation is always better than the romantic tool.